thank you for coming for this session. I know it's hard to be in the last session, but we'll try to make it short and interesting. And feel free to ask questions during the session. We try to be interactive as we can. And let's start, right? Valentina, go ahead. Introduce yourself.
Yeah, of course. So I'm Valentina Rodriguez Sosa. I'm a principal architect at Red Hat. I'm also a Kubeflow project maintainer.
I'm Doron Caspin. I'm product manager at Red Hat, currently managing the security products and working with Valentina on different projects. And all the AI issues, AI stuff are coming our way. And we try to find things and make some order in our world. And in our today's session, this session comes from real world problems. So we try to understand the problem, try to understand the issues. And we'll talk about, this is our agenda today, we talk about AI safety versus AI security. We talk about MITRE attack and MITRE Atlas, the two frameworks that leading the market today, all kind of other AI framework, risk convergence between AI and regular security, all kind of open source tooling that can help us support and protect our AI workloads. And of course, a demo in the end. And I hope we'll have a lot of time for demos and questions. So let's start. Okay, this session is mostly about. We don't want to confuse between AI security and safety. So AI safety is all about unintended harm, right? We try to ask questions for LLM model and we get the wrong answers, or giving a toxic output, or we try to ask questions that are not really something that are legit, right? So, this is all about AI safety. And this is not the area that we try to address today. It's complicated, and it's, again, not in the area or most of us as a technologies handle on the day-to-day. Of course, there are tools that we try to use, but it's not our focus today. We are focused on AI security, all kind of malicious attempt to harm our models, and how to protect our AI models from people, of course, and people and processes, and of course AI processes that try to harm other AI systems. So our focus today is aligning with MITRE Atlas. I will talk about MITRE Atlas a little bit, what it's all about, and how we can use it for our benefit. So we are seeing, of course, you see everywhere, AI is exponential race, exponential rise. A lot of AI models, a lot of LLM models deploy in Kubernetes or other models. Most of the LLMs that you see out there in the wild are deployed on Kubernetes. We have additional capabilities that keep exploring LLMD, other tools that bring VLLM, that bring easier way to deploy LLM models on Kubernetes. And we have our traditional way to protect our Kubernetes environment. And again, these tools are not enough. They are not enough to protect our LLM models. And we need to attack and build a model around how we really protect the AI model as part of our story of the evaluation of security. And yeah, so this is the major 7 areas of attacks on AI models or AI systems. So the first one is the most dangerous one, or most common one, is data poisoning. So if adversaries try to maliciously altering the training data and corrupt model behavior and introduce backdoors. So malicious actors can alter the way that we are building a model or changing the data, that a model will split out the wrong data and find a way, this way, to get a backdoor to our models. really raising area in this area, and we need a way to support it. Modification of inputs and data, and maliciously to make incorrect decisions. So all kind of data, changing data manipulation for the model, and a way we train the model. Also, privacy leakage. If we found a way, and there are some attacks already out there that was published to find that use LLM models and use chatbot to access data and privacy data and private data of customers through LLM models, through chatbot, through AI public interface for websites, and get to private data. Same as we get to private data for any website, we can go through the LLM model. Again, it's easier because when you train the model, you're usually giving access to the whole data. Even if you don't see it, when you're regular testing it, the adversaries have a way to get this information from the model. Prompt injection means that, again, very similar to a SQL injection. You promote the model with query that you're not supposed to do, okay, and get information from the model that you're not expecting the customer to ask. Supply chain attack, the attacker can compromising the development of the model. Okay, during how we train the model, how we on the process of building the model. And the last one is resource checking. So we have GPUs there, right? We bought the most latest GPUs from NVIDIA. Why not need to do some Bitcoin mining? Why not doing it instead of using it for your LLM model, right? So adversaries can run Bitcoin infrastructure on your GPU instead of running models. So really dangerous. So we talk about frameworks. Frameworks are really easy, really help us to build the mindset of security in the organization. If it's in the CISO level, when you're talking about NIST, it's a higher level. So NIST have a standard for NIST AI RMF, that is a standard for the CISO level to organize the data around security. The second level, and if you're a developer, you know about OWASP or anyone, the top 10, it's really popular, really easy to read, and it's mostly for the developers. Okay, you give the handbook for the developer how to build a better solution or how to secure a solution with top 10 for regular, with top 10 for LLMs. A lot of developers are using it. But the bottom line is Atlas. Atlas is based on the MITRE attack, very popular framework, and it provides the tactical way to address all the adversaries and all the issues that currently we know about in the market. Of course, we cannot address things that we don't know, but it's really comprehensive. And if you go to the website, we have tons of data there. I will try to do some show you later about this. So how many of you knows about MITRE attack? Okay, most of you. But again, it's really, really popular framework. We see it in most of our customers using it as a baseline. Again, it's the book or Bible for how to protect your environment, how to adversaries are going to attack your system, what policy I need to put in place, what guardrails I need to put in place. And it's really good for the level of container images, nodes, the API servers, and how adversaries are using these tactics to attack your system and how to protect against it. So in a race of course, AI, MITRE came with MITRE Atlas. MITRE Atlas is a threat landscape for artificial intelligence. It includes all the tactics, the same thing that MITRE Atlas or MITRE attack is doing, but at another level of security, specifically for AI. Example is AI model access, ML attack staging, model weight exfiltration, sorry about that, example and all kind of things that tactics that customer or adversary can use on your models in the day-to-day. We're using MITRE and Atlas, again, in the day-to-day work. If you're talking security and you want a book to follow, it's a standard language. You can talk with your data scientists, with your ML engineers, with your security team. It's one language that covers all the topics around security and AI. Threat information, it's shift focus from general vulnerabilities. Again, I need to know if there are vulnerabilities in the model, but we know it's not enough. We need the additional level. And also we have extended all the attack level with tactics, specifically for security of AI models. So let's talk about ML ops or ML SecOps. Okay, we all know about the code one, the apps lifecycle. Most of the companies on the world is using it. Code developers are writing code. There's a build process, CI/CD process. We're deploying it in production, and we have tools for monitoring it in runtime. So we see from our perspective that AI is close enough. It's have the same process, right? We have data preparation, we have people that are training the model, we have people that are deploying the model, and we have people that monitor the model. And we need different tools to each state. And we see the convergence of the two processes to one process. And again, it's where we see the growth and where we see it coming. So, for example, if we're talking about poisoning or data pipeline, on data pipeline level, on Atlas side, we're talking about poisoning or inference. On the Kubernetes side, we talk about vulnerability data. We're talking about vulnerable container images or compromised dependency. Right? You download for model, you download the model from Hugging Faces. You think it's supporting your model, your business requirement, but it really includes all the information. It's really secure. One way, again, it's a standard that's coming in the industry. It's called AI bombs. That every model will have an AI bomb that include all the bill of materials that used to build this model. Again, if you believe in bill of materials, it's supposed to be the same model. But I don't believe in bill of materials. I think we need to scan and we need to validate that the code is actually aligned with the bill of materials. So again, we still need the regular vulnerability scanning. We still need a way to validate that the bill of materials that's coming to the world is aligned with what we really expecting to happen. So again, really close way to do things, and it's really aligned with the technologies, and again expand our technologies. And again, the best practice that we do in our regular things like avoid lateral movement or runtime capabilities to monitor that the model is not accessing IP addresses that it's not supposed to do. Processes that you're not supposed to run on your pods, right? Someone running wget on your pod. Things like that need to be monitored in the same way that you're monitoring your regular processes in runtime in Kubernetes. So okay, the challenge is here that if someone get to your pod and have vulnerability that he can use, he will get to the model and he can get the model and change the model, and it's the same level of any other code that we need to protect. I really like this diagram because we have 3 levels of support of protection, right? Of defense. We have the layer 1 that it's the pipeline, the integrity, the validation that we're running the model, and the model that we got is the really model that I'm going to run in production. The model that I bought, it's the really model. Even if I'm using novel model, right? I'm downloading a model, I'm downloading the Llama stack from a website. I need to validate that it's really the model. It's really something that I want to run in production. So again, things like model validation and air bombs. Of course, and we show it in the demo later, you need to sign the model, but no one will change it after doing the processes, doing the pipeline. So using cosign or using Sigstore to sign the model, sign the image, you can do both. And so you actually want the model that you train and use in dev is the same one who running in production, and no one can change it and run a different model with the same name. Using tools like Clair or Gripe or Trivi to scan for vulnerabilities. Again, the same vulnerabilities, the same image, you can still have Python script on models, or even any code that can run on containers can run on models and can harm. Using identity, workload identity, like SPIF Inspire model that is open source. We had a few other sessions from Red Hat this week, amazing session about zero trust workload identity, having zero trust workload identity, using MTLS. Using tools like Falco, other tools for runtime visibility and runtime management. Also, doing input and output validation of the LLM models in runtime. Validate all the time that the input and output and have a guardrails in place. And there are different tools for that. And now it's Valentina time.
Thank you, it was great. So, yeah, so we heard about Doron. I think it was amazing, explain all the different types of attacks. That he talked about technologies, and now I want to show you some specific examples of how these attacks can be mitigated using open source tools. So we'll start with Sigstore. So one of the things is, in order to mitigate some of these attacks, the Sigstore community thinks that we can do this by signing a model and providing the authentication of this model and the provenance of this model through the whole model development lifecycle. So in this case, also we can have a transparency log where we can learn from where this model was coming from. So the challenge, of course, with the model, if you want to sign the model, it has different components, from weights and tokenizers and processes and scripts. So the way that this Sigstore bundle will work, it will be creating an intermediate file, what is composed with what you see in the image, the model manifest, which has the path for each specific file, but also it has a hash of each content. So this means if any content change or any file change is maybe I don't know, deleted or replaced, this will be noticed by the Sigstore. So this will be creating a whole Sigstore bundle with a total statement for all the attestations and the signatures, and this is something that will be part of the model. So, but you were thinking, okay, great, we signed the model, then what, right? It needs to be a verification process. So this is part of the model transparency, the Sigstore project, and also we do have a model validation project that runs on Kubernetes, and the idea that is that it can run this verification before the model runs in your cluster, which is what we want. We don't want a model that is not authenticated, verified, or maybe was altered through the software development lifecycle to run on the cluster. So I will show you how that will look in a second, but also once we sign this model and we verify it, nothing has tampered or changed through the model development lifecycle, I want to make sure that also during the build deployment and also runtime, my model has the guardrails that it needs according to industry standard, but organization policies. So for that, I will be showcasing StackRox and how we can integrate and see with different CVs and policies and how that will work in order to ensure that I have those guardrails and compliance within my cluster. So how I will do that as well. Security is important, but if we think on those models, we need to focus also on the personas and the different tools that are being used in order to develop these models, right? So Kubeflow, as I mentioned, I'm a project maintainer, so Kubeflow is a foundation of tools for AI platforms on Kubernetes. So it brings a lot of different tools to make easier to data scientists to run and create these models on Kubernetes, to really take advantage of the Kubernetes ecosystem, but also the Kubernetes cluster itself for high scalability, security. So I will be showcasing all these three things. So I wanted to provide a quick intro on these tools before we are going into the demo. So I'm a data scientist. How many of you data scientists here today in the room? Platform engineering? Yay. Security experts? Great. Developers? Yeah, great. Okay, so this is great because you get to see different personas that I will be playing here. So I am a data scientist. I'm working on my notebook. I am working on a fraud model detection, right? So I am building my model, and I'm working on my notebook, and I am just testing it and experimenting. And now I will be. Let me move this more quickly. Okay. Now I am testing it, and I am looking into, for example, bulk transaction. I'm looking, is it fraudulent or not? What is the likelihood? So the model is working. Now I am ready to say the model. So I am using the different libraries that I need. I'm verifying the upload. And here I already have my model signed, uploaded, which is, yeah. Great. So I already signed my model. I have the model store. I have this on an S3 bucket. So I want to show you quickly how you can also sign the model, just to have you an idea of if I want to use a terminal, how I can do it. So I will use the SigStore model transparency. I will specify the signature. If I have an ODC token, I can specify one. I didn't specify one. So the SigStore, I will use my identity provider. So to log there, it will be, let me pause this for a second. It will be creating this token that I can use, and then it's doing the verification of my persona, my identity provider behind the scene, and it's using that to sign the model. So this is great. So I wanted to show you, but you can do this, of course, in an automated way, right? In a CI/CD pipeline and so on. So here I have in my storage, in my object storage, I have the model, but also I have the model signature. So now I want to go into a cluster. So I already have OpenShift, which is Kubernetes, enterprise Kubernetes, but it could be any Kubernetes. For the purpose of this demo, it's any Kubernetes. And the way that I will be doing, so I signed the model, now I need to validate and verify it. So what I will be doing, I will be creating a custom resource definition. This custom resource definition needs to live on the same namespace as my model, and I will specify one name that I need to copy later to use it on the pod that my model will run. So I will do that, and the other thing that I need to specify is the certified identity and the issuer. So I will do that. So as you can see, I'm using the Google's accounts. I need to provide the model path and the model signature, and this is what it will be used behind the scenes for the verification. So once I have that created, I can deploy my model. So here, I want to deploy my model, but because I am a data scientist and I want to use the best tools ever in Kubernetes, I want to use Kubeflow, and I will use Kserve to serve my model. So I am a data scientist. Maybe this could be part of the MLOps engineer who can do this right for me. I am using configuration as code, so I am not creating the object directly in the cluster, right? I'm creating this on a source repository. And in this case, what I need to do is just I need to specify the label, a label that says validation ML SigStore. and then I need to provide the same name of the custom resource definition that I just created. In order for that, so behind the scenes, there is a controller that is matching that model validation controller that is just created, and it needs to make sure, it needs to see what is the pod that I need to watch for verification. So that's why I need that label. So now I'm moving into like MLOps, right? And using Argo CD in order to ensure that what I created on the source code repository is always my actual state. So desired state versus actual state. How many of you using Argo CD who have heard about it? Great. Yeah, it's really amazing. So we'll ensure it will read from the source code and it will apply those configurations on my cluster. So with that, I'm just deleting just to see that this is working and just forcing Argo to quickly replace my options. So now what happens is the inference is creating a deployment object, which is creating a replica set, which is creating the pod. But the label is all propagated all the way to the pod. So, and what will happen is once I have that label on the pod, there will be an init container injected into the pod. That init container is called model validation, and that it will run before it runs the container with the model. So we'll do the verification. In this case, it's like, well, it's in someone changed something, so there is a mismatch. So it's not working. As you can see, the pod is not running. So after this, what I will be doing is I will be removing the signature. So I am just removing the signature from here, and what will happen is the pod will get, I am just forcing the recreation of the pod, and we can see in the logs that they cannot find the signature. So it's trying to make the validation, they cannot find the file. So what I want to show you with this is an attacker wants to alter the model, the weights, right, the tokenizers, the signature, there will be mismatch, the model will not run on the cluster. And with that, we are moving into, after the verification, we said we need the guardrails also to ensure that when that container is running on my cluster, it has all the guardrails that I need with the standards in the industrial run security, but also I want to make sure that at runtime it behaves as it's supposed to. So I will start looking into the risk. So the risk, for example, allows me to look into the different process of that container to understand what's going on. And this is a tool that I can use to also create new policies in my cluster if I see something that it shouldn't be running on the cluster. The other thing that I want to show you right now, you are seeing a chatbot. It's not a model. So yeah, surprise. But with this, we want to show you that the same things that you're using for validating a container, you can use it for a model, you can use it for an AI agent, you can use it for an AI application. And the other thing that I'm showing here is, for example, the policies. And here we can see that the image was not, the container image was not signed. So I can explore also the different policies and what's happened with that specific deployment. I can look the network policies and the policies violations as well, which gave me the security as well, as you can see, if it's high, is it low, which helped me prioritize it and see what are the things that I need to focus in order to fix it. So I am here looking at the model. So I am changing back and forth between the model and the AI application. So for you to see, here I added the AI application again, so we see that we do have, well, it's worse. We have high policy violations. The container has not been signed, so it's kind of a mess. So we should be talking with AI engineers, right, and add policies also to ensure that that cannot run on my cluster. So the other thing that I can do within the vulnerability, I can see the CVEs, I can see the severities, I can see which ones are high or medium, so I can address them. But also I can see which ones are fixable. So I can talk with my team and say, hey, you need to fix this, and which ones not. So last, I know it's been a lot, but the last thing that is important is, of course, the network, because attackers are always looking as well for different places. And looking into a network graph where I can see where my application or my model is connected. What are the network policies? what is the ingress, what is the egress, is very important as well. So here there is a graph where I can see, oops, it didn't finish, but really good. The model mesh graph. Let me just pause it here. And I can see there is a missing policy to allow all the network traffic. And with that, I finished this demo. I will, let me see if I can, yeah, so some key takeaways. Let me maximize this. Okay.
Yep.
That's fine. So we saw that MITRE ATLAS provides this foundation for AI threat modeling. Open source tools make AI security more practical, like taking all those concepts and implement it. We also look into the different controls that we can implement during the model development lifecycle from the data scientist persona, but also ML ops, even AI platform engineers who are looking how they can bring those tools to the data scientists, but also how as an AI engineer, when I'm building like a chatbot or an AI agent, what are the tools, or how we can ensure that those new applications are also within our organization guardrails, right? We can utilize the same processes. So the other thing is start mapping AI software development lifecycle to Atlas today and implement a strict zero trust micro-segmentation and network policies is great to do that. And of course, workload identity that Doron talked about today, and runtime monitoring like from Falco as we saw as well on the demo. With that, we do have some resources. There are many projects in the community within the cloud native ecosystem and other open source projects. So, but also Kubeflow community meetings if you're interested in learning more about Kubeflow, and also learning more about StackRox that I show on the demo. And with that, I want to say thank you. And yeah,
thank you very much.
Yeah. Yes.
Yeah, I have one question. Thank you so much for this presentation. That was very interesting. I understand right now why it's important, to sign a model. But, if we step back, and for example, if I'm a developer, I'm pulling a model from a guinea phase, as cloud security team, before to sign the model, maybe we want to run the model in a sandbox, to try to check all the behavior of the models, I'm curious to know if you have any open source projects which can be used to do that, or any recommendation about that?
To sign the model once you download it, or to run it on a sandbox?
To validate it before you run it.
For the model sandbox.
Yeah. So you can. So something that we are looking into, what we are doing is, as soon as you download the model, you can sign it. So that ensures that the model.
First, you need to validate the AI bomb, right? It's something that it starts being a standard on Hugging Faces. The other one, you can basically start a new cluster that is separate, right? It is gated by network policies, but not connected to other cluster. We don't have a tool specifically for gated environment, but having Kubernetes is perfect for that. That you can set up a workspace, a project, or a workspace, or just launch a new cluster, a separate cluster, a very small one, just to try it out.
Yeah.
Perfect. Thank you for this answer.
And
second question.
Okay. We have some links to some tools on the slides to test the model. So, yeah.
My second question is related about the data exfiltration. In your conclusion slide, you put, Falco can be used for data exfiltration.
Yeah.
In this case, which type of, when we are speaking about data exfiltration, it's what? It's TLS decryption, and you will inspect what is in the data payload for the.
Exactly. Yeah. And again, if the model try to access different website outside of your network or other way around, right? Or you again, we found that someone tried to run wget from the model, right? So you want the network traffic and the process baseline to be tracked and to be have alert on that, have information on that.
Perfect. Thank you so much for that.
Of course.
Thank you.
Thank you.
Of course, thank you.